Next, I want to discuss what is at the center of our galaxy. And it is not visible to us. First of all, it is in the direction of constellation Sagittarius. And it's not visible at visual wavelengths. And it's not observable at visible wavelengths because the gas and dust in the disk blocks those wavelengths. And I mean, I'm sure you've heard about supposed end of the world in 2012 based on all kinds of things, Mayan calendar, this and that. And one of the things that was listed in that doomsday scenario was that on the day of winter solstice, right, the first day of winter, the Earth, the Sun, and the center of the galaxy are aligned. That happens every year at the winter solstice, right? Every year around December 22nd, it just happens that the configuration of Sun relative to the Earth and the center of the galaxy is that they are all on the same line, right? So people should learn more astronomy. However, the center of our galaxy is observable at radio wavelengths and at X-ray wavelengths. And the reason is that the radio waves can actually go through these, because of long wavelengths, they can bypass the obstacles in the interstellar material, gas and dust, and reach us here on Earth. Also, X-rays that are being produced, and there is a very strong source of X-rays, as we'll see a bit later. X-rays have so much energy that they can just push through the gas and dust and reach us here on Earth. So galactic center is observable at radio wavelengths and X-ray wavelengths, because these types of radiation can pass through the gas and dust. Okay, and next I want to show you the radio image of the center of our galaxy. And let me open a new page. Okay, that's good enough. So these colors, of course, are artificial colors used to render the image, but they represent different intensity of radio waves. And you can see several features at the center of our galaxy. For instance, here are supernova remnants, right? These big donut-shaped features. There are a few other peculiar things like snake here, this radio arc, and at the very center of this is so-called Sagittarius A. Okay, and often it is denoted as SGR A, and in its core there is a very intense source of radio waves. So I'll show a combined radio and X-ray image of the very core of Sagittarius A. SGR A and then star. Okay, so when we take the close-up of this central part and we take a close-up both at radio wavelengths and X-ray wavelengths, we get the following image. Okay, so I'll open another page so I can fit it in. And here it is. Okay, so when we take a close-up of this SGR-A region and look at its core, this is what we find. So here is Sagittarius A star, this intense source of radio waves. The blue color used to render things corresponds to radiation at radio wavelengths. And the one in purple corresponds to the source of X-rays. And in X-rays, there is an image of a jet that is related to a very massive black hole that is actually at the center of our galaxy, and it's powering Sagittarius A star. It's providing this source of radio waves and X-rays with energy. So astronomers, by observing how the stars and gas and dust move around the galactic center, the very galactic center, they can calculate the mass of this central object, just like we always do by using the third Kepler's law as formulated by Newton. And the result is astonishing. The mass of the central object is 4 million solar masses. So something that massive can only be a black hole. But such black hole must have been formed in a very different way from the black holes that we've discussed that are left behind a very massive star when it explodes. Those black holes are typically from 3 to 10 or so, maybe 20 solar masses, but you can't get anything this massive from an exploding massive star. It's just not possible, okay? So that's one thing. The second thing is that when we look at other galaxies, we find the same thing. We look at their centers, we measure the orbital data of the stars moving around close to galactic center. We apply the third Kepler's law as formulated by Newton, and we find that virtually all galaxies have such supermassive black holes in their hearts. So there's something intimate between galaxies and supermassive black holes. They always go together, okay? And that's one of the mysteries that astronomers or astrophysicists would like to solve when they consider the problem of galaxy formation, but we'll talk more about that later.